exactly, the directory might be some 72 miles thick.
The capacity on the ith channel should be the traffic on the ith channel over the speed of the ith channel plus how much is left over. That's how much capacity is left over, and you split it according to the square root of the traffic on that channel over the summation of the square root over all channels.
The way that the internet works, there's no fixed route that a message takes. In the early days of the protocol, there was a kind of a bug, and one of the computers actually had a hardware failure that made it believe that it could get a message to some place in negative time. So of course, every message in the internet did better by sending it through that computer because it subtracted the time that required to send the message. And so all the messages in the internet started getting sent through that computer, which of course got slower and slower and slower. So the internet kind of started to grind to a halt.
The mean response time now will look like this. It will be equal to the average path length times the summation of the square root of the traffic on the J channel over the sum of all traffics, summed over all channels, squared over UC 1 minus n bar rho. Whatever that equation means, it tells you what the minimum response time will be for a network once it's optimized.
The computer was claiming that it could deliver the message before you even sent it. So if you had a post office like that, of course you would use it, right?
This was a simplified but exact model at the time. Now we have other aspects of it, but it's basically the underlying principles of the network, and one of the things we found, surprisingly, was that the larger the network is, the far more efficient it becomes.
Like a gambling casino that suddenly makes money if you have millions of gamblers at the slot machines.
Very much so. You've articulated what we call the law of large numbers. The law of large numbers says that a large population of unpredictable players or messages collectively behaves in a very predictable fashion, a fashion we can write down exactly. And therefore we can predict the performance of a network when it's large.
The underlying technology